Going back on stage with execution stage now. So for this session about low-cost device reference design, we'll have Danny from Amosense, Carl from OpenRF, Paul from Sigfox, and that panel will be moderated by Christophe. So please join the stage and join me to welcome them on stage. Thank you.
Thank you very much. Thank you. Welcome, everybody. Hello, good morning. We are together for the next 20 minutes to discuss and to share about the Sigfox low-cost device reference design. And with me, some brilliant partners to talk about this. So as has been introduced, there is Paul Pinault at my right, famous owner of this91.com blog, also founder of Ingenious Things, and working at Michelin in a connected IoT department, but anyway, so several disciplines. I have Danny with me also. Danny, Chief Marketing Officer at Amosense. Carl Zhu, Sales and Marketing Director at HopeRF, CMOS Tech, which is in the same group. Thank you. And myself, Christophe Geloyan, I'm Director of the Network Technology Engineering at Sigfox. Just as Christophe Fourtet said this morning during the opening keynote, Sigfox is more than a technology, it's also a complete cognitive systems, SDR-based, that has the capability to evolve, to improve, to increase its capabilities in order to manage more and more device imperfection, I would say, and absorb complexity inside on the networks. And that, for the sake of the device simplicity, the cost and current consumption reduction of devices. So you remember maybe 2 years ago in Prague, in the Connect event, Christophe Fourtet had made the demonstration of the feasibility to send a Sigfox message by opening a letter, so with a simple trigger, using very few and cheap components, bill of material. That was the demonstration, and today we are ready for this, as Christophe Fourtet reminded. We are ready to make this thing industrial and a reality. So what did we do since today? At Sigfox side, we worked in making evolve our network infrastructure to be capable to receive massively message from very simple and basic transmitters that are available on the market right now. And those transmitters have different signal characteristics, so that's why we have made this evolution in terms of network capability. In parallel to that, we worked as an ecosystem enablement effort. We worked in designing a reference design of one device, implementing one of those simple transmitters coming from HopeRF, in order to make available to the ecosystem something that works on that infrastructure. And that reference design has been put it in a demonstrative button that has been used this morning, that you have one, I guess, for the bingo game, okay? Sorry. Well, so what is inside this button? So basically, this is the content of the reference design. What are the main characteristics? It is RC1 only, transmitter only, so uplink, no downlink. We have a power class 2. The Sigfox authentication mechanisms are the same as usual. We have a predefined message that are stored in the memory of the chip, and is coin cell powered. Anyway, and it is there is a simple trigger, which is a button here, but please note that any trigger can transmit a message with that. Here we choose a button, but any binary event can be the generator of the message, like a door opening, like a threshold overpass, like a full tank, empty tank detector. Anything that is binary can be the source of the generation of the message on that. We make today available this reference design on the website build.sigfox.com for anyone from the ecosystem who wants to do products based on that. Well, I'll come back to that later, okay? But now I would like to give the floor to Danny, that has from Amosense. We introduced upstream Amosense in this project, in this initiative, in order to have its industrial, as a device maker industrial, its standpoints. Danny, please.
Did you enjoy the bingo game over there? I'm so excited. Okay. I'm so excited that I want to share the ultra low cost device, what we call zero-G button. Okay. As you know, the Amosense is a manufacturer a lot of different LPW IoT device. So we got a booth over there. We have the asset tracker or in the button, environment monitor the device. We got a lot of different device. Okay. This device then have a monarch picture. And, now, yeah. I want to share the real ultra low cost device. Now, as you see, this is the button. Yeah. This is the stick. So there we call this one. Can you get this one? We call this is a neon Q. This is a neon Q. Yeah, we call it the neon stick. Yeah. So we have a different form factor. So you can see over there our booth. And we have a different product. This is a stick. This one has a 2-coin battery. And this one has a 1-coin battery. It depends on the use case. You can select different the ultra low cost. So you can use this product several applications. For example, you can use this device for callback service or marketing promotion service or service maintenance. There's a lot of use case. So there are. I think this device, ultra low cost device, will be game changer in this industry. So we decided to make this the device.
Okay. Thank you, Danny. Just coming back, we say low cost reference design, but what does it mean? Here, in terms of reference design, the electronic bill of material of this reference design, we estimate it at below 60 cents in volume. So of course, those numbers has to be confirmed depending on volume, depending on the purchasing, the negotiation, and so on. And it is not representing the price of a device. The price of an end product should be discussed depending on use case and so on. Anyway. Another point, we made evolve this our infrastructure to that, so as we made evolve the radio specification and certification criteria for Sigfox, but there are just relaxation of specification, which means that all the existing ecosystem devices are still fully compatible with the network, of course. And we will release those specifications next February officially. But the reference design is available right now on the website. Okay? So now I will give the floor to Carl as we choose one of their products in this reference design, which is the CMT2189. So please, Carl.
Thank you. Who is Hope I've? Hope IF actually it was set up in 1998. It's a professional vendor for the IF products and the men's products in China. We are supplying to the market with the IF products, including the FSK and OOK IC, the FSK and OOK module, and the Wi-Fi module, the BLE IC and module, and LoRa module, and the Sigfox module as well in the future. During the last 3 years, our business has been increasing rapidly, achieving about 30% annually growth rate. We're shipping more than 15 million pieces FSK and OOK IC to the market monthly. And as a core business, Hope I've committed to support with the higher performance, better quality, and the lower pricing solutions to the market. Our company continues to provide the strong roadmap of the app solutions of the higher-end FSK transceiver solution, high density SoC, and better performance towards cost solution. About the MEMS product, we are providing to our customers with the very high precision pressure sensors and the temperature sensors, which are widely used in the consumer market and the industry market. About the 219089C, which is introduced in Sigfox low-cost SoC, it's an SoC in SOP14 package, FSK OOK modulation with up to 13 dBm power output, with an 8-bit PIC MCU inside, 2K word flash, and 8 I/O interface. The IC is widely used into the room remote controllers, such as the garage doors controller and the PKE, the RKE as well. And the pricing about this part is about below 0.3 US dollar. And we commit to improving our manufacturing costs in order to support this project with a lower cost in future. As the volumes, of course, with the volume grows up in the near future, we will keep the high quality as we used to. Besides of the 2189C, we have the new ICs, which is 2168. Inside it, we have integrated the 125K RF receiver, high performance 8-bit MCU, and 8K RAM, 8K OTP memory, with the FSK transmitter up to 13 dBm pulse output, with the AEX 128 acceleration agent inside it. We have 3 packages. One is TSSOP28, QFN32, and the other is SOP14. So in case the market needs a larger memory, better security, or even with 125K RF receiver, in some application, we can support the market with this IC. Of course, if our partners need any new features about the products, which we can support in future, please don't hesitate to contact me. Thank you.
Thank you, Carl. Thank you very much. And to finish, without particular transition, I will give the floor to Paul, because he was informed also upstream on this initiative, and he has the opportunity to have the design in his hand. So please, can you share what you did until today, and what do you think about that?
Yeah, sure. So you know, I'm a blog owner, so I'm on the sk91.com, and I'm a hacker. So when Sigfox involved me in that project, it was really cool for me to see a new technology and a new way to have Sigfox at a really low price level. So I've started this by understanding the technology and describing it. So you can find many information on my blog site about what is the $1 technology for Sigfox, or ultra low cost technology for Sigfox. And also you have on a post I've published yesterday the detail of what is in the button. So if you want to check the price and so on, you can do that on my website. So as a maker, when I was involved in that project, I decided also to make something with it, not just try to describing from what I learned from Sigfox, but also to make it, to see how it can be easy or complex, and what I can do. So this is what I've done with this device. I say I'm a blogger, but I'm also a device maker. I founded a company, Ingenious Things, and we are running a tracker business since I think 6 years now on Sigfox. So we have a good experience on tracking, and we were looking for making a such product since many time, thanks to the Atlas geolocalization system that allow to locate any device from Sigfox network in around 5 kilometer precision. So we know that there is a lot of things to do with that, and this low-cost technology was very interesting. So that's why I made this device based on the reference design. Just before, sorry. What does this device? It's just sending a signal on a frequency basis of 2 hours. So we are 10-day autonomy on the simple CR 2032 battery. Basically, the battery can live about 20 days, but we limit it to 10 days. And it has a simple sensor, like it has been explained, a binary sensor, just detecting light. So if you put it on a parcel, when the parcel is open at reception, you get a message. And all around the trip of the parcel, you get message with location, so you know where is it. And we had time before the event to send some of this device to the ambassador community. Thanks, Guy, to be there. and some of them have a trip going to Singapore. So the device I've sent from my city in center of France to Paris, London, going to north UK. Then our friend goes to Sweden, back in London, and then gone to Abu Dhabi, and so on. So you see that with a simple device that costs about less than $1 in BOM, you can easily track something and see it all over the European zone. So that's very interesting. You can go to the next, please. What is interesting, if you want to have such device, to make a such device, you have to go through different steps as usual. What I can tell you from my experience is building a such device from the reference design, it's something really easy. I spend less than 5 days, and I think that on a 5 day, I spend something like 3 days making the compiler working. So now the solution is online, so you will save that time. So from the ref design, making the object is really fast. But you have to have a hacker mindset, because it's not like you're programming a STM32 device. Okay, you have a teeny memory, a teeny flash space. You have a big 8-byte compiler. Okay, so it's more hacker style things. But it's really interesting. I love this personally. Then you need to go to industrialization. And in fact, the industrialization phase is a more important step for this kind of device, because if you want to have a low-cost device, you really have to save time during the industrialization and making a process, because you have to program it, you have to calibrate it, you have to generate dynamically new firmware for every device, as the keys and the HMAC are pre-computed. Okay, so you have to automate all that stuff. So that's why I think you have most of the work. And today we still need to build some tool to automate this. We have to work together and talk. So I think it's something like 2-4 months to have something which is quite good to do that. And don't forget that, in fact, in such low-cost project, where you're going to spend more of your time is not to build the object, is to build the platform. If you want to do a tracking solution like we do, or a platform for the tracking system, it's about 6 months of work, because this has also to be scalable. I mean, we don't do a such project to have 1,000 devices. Okay, if you do a really low-cost device, it's because you are targeting 100,000 or 1 million devices. So your platform needs to scale to support that. And in my point of view, it's here that you have most of the work in such project. So that's my feedback on experience on this. I will continue to develop that technology. So follow me on DASK91, and you will be updated on what I'm doing. I'm usually sharing on my or what I'm doing. I love to share things. So
Thank you very much, Paul.